So if you've been working on the summer pre-calculus refresher problems, on page 13, you're going to encounter some advanced factoring challenges in problems 23, 24, and 25. And so I just want to take a quick second to run through an example of this to remind you about the techniques that you use for factoring. This is a one-take situation, so we'll see if I can get it right the first time. First of all, I want to remind you in general how we factor some of these polynomials, and then we'll talk about these more complicated expressions. So remember, the idea behind factoring is to look for common factors in the terms. So for example, here we have a term, and then here we have a term, and here we have a term. The terms are separated by addition and subtraction. And what we want to do is look for common factors in each of those terms. So for example, you'll notice that the coefficients all have a GCF of 5, right? 5 goes into 20, 5 goes into 10, and 5 goes into 5. That's the greatest common factor. That's the biggest factor that we can pull out of those coefficients. So we usually write that thing down, and I'm going to keep that in green because that's the color I use to identify those. And then when we're looking at the variable terms, what we look at is the powers of x. And the way we find the GCF for those power of x's is we take the lowest one. So here the lowest power is x squared. That means we can grab an x squared out of an x cubed and an x to the fourth as well. So I'm going to write that factor here as x squared. So you pull all those, you factor them out in front, and then you divide each term by that GCF, and you end up with the leftover term, the remainder. So 20 divided by 5 is 4, and x squared divided by x to the fourth divided by x squared. Use subtraction on the exponents to get x squared. So 4 minus 2 is 2, and I have that term done. Then I have a plus sign. Then I do 10 divided by 5, which is 2. Subtract the exponents, 3 minus 2, and I get x to the first. And then 5 divided by 5 is 1. Oops, that's a minus sign, isn't it? Let's see. Oops, I just highlighted instead of erased. I told you I'm doing one take on this thing, and now it won't let me erase. I don't know. Come on. There it goes. So there's a minus sign here. 5 divided by 5 is 1. And for the x squared term, we took the whole thing. 2 minus 2 is 0. So there's just x to the 0 there. And so now we have this thing completely factored. I suppose if I'm being really thorough, I'd check to see if I can factor this trinomial, and I don't believe I can. I'm just rethinking that now because I made this problem up on the spot and I wasn't careful. But in general, that's how you factor out that common factor. Let's use those concepts to try and attack these complicated problems. And what I'll do is I'll just pick one of them and show you how it goes. So I'm going to go ahead and pick out number 24. Number 24 has one negative exponent and one positive exponent on a common binomial factor. So I think this is a good one for us to use as an example to remind you how we attack these things. So remember, these expressions, the terms are separated by either a plus or a minus sign. So here's the plus sign, and that means I'm going to be looking at the first term, 2x times the quantity x minus 1 to the negative 1/2, and 5x times the quantity x minus 1 to the 1/2. So notice, as I'm looking at these, there's a monomial factor, and then there's a binomial factor. I'm going to look at the monomials first. I've got the 2x and the 5x. The common factor for those is just an x. So I go ahead and write that down. I factor that out. That means there's a 2 and a 5 still left over. Then you'll notice that I also have the binomial factor of x minus 1 to the 1/2 and x minus 1 to the negative 1/2. That's a common factor. And remember, we pull out the lowest exponent. So as weird as this sounds, I'm going to factor out an x minus 1 to the negative 1/2. And that's the GCF for that piece. So now we have to figure out what's left over when we do this factoring. So when I do 2x divided by x, I end up with just a 2 left over. So there's a 2 factor there when we deal with that first one. I took the entire x minus 1 to the negative 1/2. When I divide those, it turns into 1. Negative 1/2 minus negative 1/2 is 0. So that factor's done. Then there's the plus sign from right here. When I do 5x divided by x, I get a 5. And then this is the one that's weird. When you do x minus 1 to the 1/2 divided by x minus 1 to the negative 1/2, 1/2 minus negative 1/2 is actually 1. You add those two. You add the 1/2 plus 1/2. So I end up with a x minus 1 to the first power here. And so now I've got this GCF out here. Let me get another color here that we factored out, and these are the leftover terms. And now we just need to write out the simplified form. So what I'm going to do is distribute the 5 and then finish this off. So I end up with the x minus 1 to the negative 1/2. Don't worry about writing that in radical form. And then the 5x minus 5 plus 2 would be 5x minus 3. And this turns out to be the factored form for that thing. There's more we can do algebraically to make this look a little nicer with radical form and making a rational expression. But for what we're trying to achieve here, this is fine. And if you made it to this spot, you did a great job. So good work. Hope that helps. I know I talked a lot, but it's early in the morning and I'm just getting warmed up. Take care.